Well, welcome everybody. We've got a good mix here in the office, and we've got a good number of people online. We are kicking off the first of our Fireside Chat series. The goal of this series, which we'll be doing throughout the year, is to give all of our team members more exposure to our senior leaders and have them up here in the hot seat to talk about some of the most important topics facing our industry and our company today. So I'm very happy and thankful to have Matt Bonakdarpour, our Chief Technology Officer and President, be our very first Fireside Chat guest.
Thank you for having me.
So, all right, we are going to dive in to talking about AI, something that we hear questions from analysts, investors, media, and at least 10 of you every single all hands. So for that reason, we promised to do a deeper dive, and that's what we're going to be talking about today. You can submit questions in real time. We're going to chat for a little bit about some of the topics and questions that have been sent in advance, and then we'll spend some time answering the specific ones you're sending in real time at the end of our chat. Okay? We've also decided that as we do these fireside chats, we want to make sure you walk away knowing a little bit more about our leaders personally. So we're going to start off with a couple questions for Matt, just so you can get to know him. Matt, tell us about your home life. Pretty quiet?
Pretty quiet. I've got 4 young kids at home, all under the age of 5. I have a 4-year-old daughter, 3-year-old son, 2-year-old son, and a 5-month-old daughter. So pretty calm, stable home life. Not a lot going on right now, but it's a joy, and it's extremely chaotic.
Can we share the fun fact of what inspired Ada, your oldest's name?
Ada is named after Ada Lovelace. Some call her the first computer scientist, a really impressive woman from hundreds of years ago who I think the story is that she invented perhaps the first algorithm or the first computer. And I always thought that was an inspiring story for a lot of different reasons, especially in that time period, and I also love the name.
Because you have so much free time, what kind of hobbies do you have outside of work and parenting? Is there time outside of work and parenting?
Hobbies have kind of taken a backseat for me in recent years. I've really got root and family that takes up most of my time. When I can, I really love going backcountry camping and exploring the national parks in America, and I've seen a lot of them, and I hope to see all of them, and can't wait to start bringing my kids on those trips. But that's probably been the only enduring hobby over the last 10 years or so.
Talk about Matt as a kiddo. Any early signs that you would be heading into a technical career?
I always kind of leaned towards the science and math classes, but the hobbies I had as a kid were, I spent an embarrassing amount of time playing computer games. First StarCraft, for those of you who played StarCraft, and then later Counter-Strike. It took up an enormous amount of time. So I had part-time jobs growing up, went to school, and every other moment was probably playing one of those games.
Excellent. I think you're in good company.
Yeah.
All right, so let's talk about your educational background and early career.
Yeah, so I went to school in Pittsburgh. I wasn't really sure what I wanted to study. I knew it was going to be something technical or leaning that way, and I bounced around a lot. I started as an engineer, and then slowly over the first year and a half of school, I got more and more theoretical. I went from engineering to computer science, from computer science to pure mathematics, and then I landed on philosophy, and I was a philosophy major. And I remember I emailed my parents the day I changed, and this is like the 4th time I'm emailing them, and I'm like, they're probably not even reading these anymore every time I change my major. But shortly thereafter, my mom called me basically crying. She was very emotional. She's like, philosophy, what are you doing? We traveled to this country and we're paying all this money for college. What are you going to do with a philosophy degree? And so that forced me to do some self-reflection. And so I kind of backpedaled a little bit. I ended up majoring in computer science and math. And it turns out I like those areas more anyway. But I happened to go to school at a university that had and still has a machine learning department. Mm-hmm. And this was a long time before there was like open coursework for machine learning. And so I got access to formalized curriculum at a time where it wasn't really available. And that got me really interested in applied statistics and machine learning. And after that, I went into quantitative finance. I worked for the hedge fund Citadel in Chicago for about 5 years. I worked on high-frequency trading strategies and statistical arbitrage strategies. And it was influential in a lot of ways for the way I think about solving business problems, how to leverage applied statistics, when a human should be involved in a decision, when a machine is better at making those decisions. It was a remarkable story. I joined at a time when they were revamping their high-frequency trading team, and I saw it grow from the 5 of us to hundreds, and the strategies we deployed were #1 in trading volume across the major electronic exchanges. And a lot of what I learned there about how to use statistical techniques in a business setting influences the way I approach the insurance problem. After that, I went back and I got my PhD in statistics. And my thesis was like basically 3 completely different projects just stapled together. Sometimes people have a theme. I had no theme. It was all just different methods that I thought were valuable. But one of them in particular leveraged language models, not large language models, but language models. And so I did a lot of learning and thinking about language models. And so this new wave of AI that's coming out now, I felt prepared to understand some of the core methodologies.
So let's talk about this new wave of AI. How do we define AI today? Maybe how has that evolved over the past few years?
Yeah, this is a great question because I've been getting a lot of questions like this internally and also from investors and others. First of all, I think you'll agree as the Chief Communication Officer and Chief Brand Officer that the branding of artificial intelligence is remarkably good. It's a great brand.
Yes.
It inspires thoughts of computers imitating humans and kind of just lets your imagination run wild. And so over the last 4 decades, at any time there was any progress on artificial intelligence, it got immediate media attention, hype cycles would start to go, and then historically never quite hit the expectations we were expecting from something called artificial intelligence. But for the last 30 years or so, when we use the phrase AI, and we've used it at Root a lot over the last 10 years, what we were referring to predominantly was a subfield of AI called machine learning. And machine learning basically was a core part of the Root discipline from the moment of inception. And it's a discipline that uses a combination of computer science, statistics, and optimization to process data, make predictions, and then eventually help with decision making. And so I also like to call machine learning predictive AI. And that's really what we've been talking about for the last 30 years. It really became prominent in the 90s. There's some forward-looking companies that leverage these tools for like mission critical back-end processes, like Amazon used it for fraud detection, supply chain management, recommendation systems. A lot of financial firms used it to predict the future asset prices so that they could trade on it. But it was very much a prediction task. And at Root, for example, we want to predict who's likely to get into an accident, who's likely to bind or buy our policy, who's likely to retain. These are all prediction tasks that are uniquely suited to the machine learning domain. More recently, really what has captured the attention of the media and all of us and venture capital firms and a lot of investors everywhere is what you might call generative AI. So this is different than machine learning. It's a different area. And it's called generative AI because a lot of these tools that have been making remarkable progress recently generate things like text, video, code, images. It's not really the prediction problem that we've been solving at Root. This is a different type of problem it's solving. And that's the difference. That's when we talk about AI and you kind of put a microscope on the field over the last 4 decades, what we talked about in the past is different than right now. So in some ways we've been doing AI from the beginning. In other ways we have to change the way we're using these tools because these generative tools are different. They're different than what we've been using.
Mm-hmm. So talking about the brand of AI, how much of that, or what parts of that do you feel are hype or fluff, and what parts of that are real, informative?
I think there's always a lot of hype. So AI over, again, since the 50s has gone through cycles where some remarkable discovery would be made and it would start to heat up. Research labs would be spun up, investments would be made, and progress would be made. But the expectations of the methods always outpaced what actually happened. And you always ended the end of that cycle better than when you started. The methods were better, they were useful, you had new products, you had new scientific discoveries, but never what you would expect. And whenever they fell short, then the cycle would end and you would enter what people call the AI winter. And we've had many winters over the last 40 years or so. We're in the hype right now. And so I have no reason to believe this will be any different in terms of, I think we're going to develop some remarkable tools on the other side of it. I think some expectations will be missed.
All right, let's think about now, the big question that we get all the time is how does this connect to Root? What elements of AI are we tapping into? And then how are we using AI internally?
So, like I said, we've been using machine learning from the very beginning. And so that has kind of made its way through all of our policy life cycle from beginning to end. From the marketing models we've deployed into production to the pricing decisions and the quoting eligibility decisions, the billing schedule we offer to a customer. In the claims world, we have models deployed in production that flag whether a claim looks suspicious and maybe a team should look closer at it, whether a vehicle should be considered total or repairable. So we've been using these machine learning models and continue to deploy them, hundreds of them, for a lot of things on the policy life cycle. And then we are also using them in advanced business intelligence, so predicting who might buy a policy, how long will they retain, what's their loss ratio going to be. This helps us understand the value of a customer from a financial perspective and allows us to deploy our marketing spend. So that's the machine learning side of the equation. On the AI side, we started back in 2023, and maybe giving a little bit of a history of some of these models would be good too, because it kind of flows into how we use it at Root. And it gives you a background of why now? Why is this all happening right now? So maybe I'll focus not on the machine learning development, but on the AI development. So a little bit of the history there. Trying to think of how far back to go. So I think if you go, so where artificial intelligence was coined was in the 50s. So there was this it's really famous now, this meeting at Dartmouth College. It was like a meeting of the minds. Some psychologists and computer scientists and people kind of in and around what you might call artificial intelligence now. They all met with the proposal that all human learning and intelligence could be imitated by a computer or simulated by a computer. That was their proposal. And they were trying to create a research program that would show that's true within a generation. And so they missed a little bit on that, but they coined the phrase artificial intelligence in the 50s, and they started to build models to imitate humans. And so there were a lot of vision-based models built then, and actually the smallest building block of a neural network was invented around that time called a perceptron. So that's just like a single neuron within the neural network. And you feed it an input, it gives you an output, and you dial a knob until the output that you want is what the perceptron grid gives. And a lot of the approach in the 50s and 60s was logic-based. Like if you want to simulate a human on a computer, you should encode the rules of logic and encode the rules of symbol manipulation. So being able to manipulate mathematical symbols. It took a lot of human engineering to get those systems working, and combination of that not being efficient, not enough compute, not enough data, you entered an AI winter until the 80s when neural networks kind of had their second moment, and that's when this this methodology called backpropagation was invented. And that's just a fancy way of saying we can dial all the knobs within a neural network more efficiently than we could before. And we made some progress on that front. But again, not enough compute and not enough data. It didn't meet expectations. We entered another AI winter. And then we went into the 90s, and for the most part, that was the era of machine learning, which I've already talked about. And there were always like researchers working on these neural networks. And I remember because I was just graduating school, there was this competition that was released in 2009 called ImageNet. And this competition was created by these researchers in Stanford, and they released something like, I don't know how many, millions of images, and each image had a category attached to it, like golden retriever or fire truck or something like that. There were 1,000 categories. And every year, what they would do is people could submit their models, and they got to compete. Who could predict what the image was the best? And whatever year that was, 2009, 2010, all the models that were submitted were all these like human crafted, human engineered, like people who had a deep understanding of the visual cortex, and they tried to simulate that on a computer, and it spent all this time just like a lot of human involvement in creating these models. And they would calculate error rates, and that's how you competed. Whoever had the lowest error rate would win. And the error rates that they started with were like 30%. So 30% of the time they got the wrong category. 2010, 2011, 2012, they'd shave away at these error rates, 30%, 29%, 26%. Then from 2011 to 2012, the error rate fell from like 25% to 15. It was like the biggest drop ever, and it was purely a deep learning model, deep neural network model. And it was the first time a model like that had really been shown to exceed all of these human engineered features on a vision task like that. The model was called AlexNet. And I think Geoffrey Hinton's lab in University of Toronto worked on that. He's since won a Nobel Prize for his work in the space. And that reinvigorated the research community with neural networks in 2012. And so more funding came to it, more universities started working on it. And from 2012 to 2017, there were a lot of strides made. A lot of people starting work on it. But the next big milestone achievement, and this is the inflection point that leads us to where we are today, was in 2017. It's when Google's research lab invented what's called the transformer architecture. So what transformers are is that they are sequence models. They take a sequence that's been observed, and they try to predict something that comes next, whether it's the next image, the next pixel, or the next word in a sentence. And these transformers, they came up with new methods that made them more effective. Those methods could be parallelized on GPUs. So if in that moment, or even if you went back in 2012, because I think that's when GPUs started to get bought a lot because neural networks started to work. If you invested in NVIDIA in 2012 and you had the wherewithal to know, it would be like a 700x return or something like that. And all of that is because these sequence of events that happened. 2017, the transformer architecture, not only did it make sequence modeling more efficient, but up to that point, sequence models couldn't be parallelized in their computation. You couldn't do computation in parallel effectively for the models, but the transformer methods were uniquely suited to be parallelized. And so that made demand for GPUs go up in a big way. And so that 2017 transformer model, that coincides with around when OpenAI was founded. 2022 is when ChatGPT was launched with a transformer behind it. So those are that's the sequence of activities that brought us to where we are today. ChatGPT was the application layer sitting on top of one of these transformers, one of these large language models. And we were definitely paying attention to it at Root. But if you remember, these models weren't that great then. They were still kind of remarkable in that moment in time, but making a lot of errors. At the end of 2023, now I'm getting to your question. At the end of 2023, we took our first step at Root, where GitHub released a tool with GitHub Copilot that leveraged large language models to do what some people at Root lovingly called glorified autocomplete. So, if you're an engineer and you're coding, it would try to complete a block of code for you. much better than what you see on your iMessage app, for example. It was still not good. It still kind of like had all the problems that we all experienced with ChatGPT. It would hallucinate. But we ran a pilot at the end of 2023 with our engineering team for those who wanted to participate. And we surveyed the engineers. We're like, is this making you more productive? How is it making you more productive? And everyone basically reported a modest improvement to productivity, not huge. It was very specific areas, types of tasks that it improved, kind of like simple boilerplate code and simple tests to be written. They wouldn't need to write the whole block of code, but that was basically the extent of it. And we've used that since then. And then in 2024, the GPT model started to really get much better and better. And ChatGPT in particular started to be very useful. So in early 25, Kyle Schmidt, our head of quantitative science, orchestrated a pilot where we used it at the enterprise. We used ChatGPT across the enterprise. And very quickly, it was almost obvious that it was extremely valuable. And it made a lot of our enterprise activities more efficient. And so we've been using it since then. We got an enterprise license, and I just checked in the last couple of weeks, we have something like 400 or 500 employees using it actively every month. And each employee is using it about 60 times a month or something like that. So that's a great adoption rate. Recently, we are now offering Gemini. We enabled Gemini in the Google Workspace, very similar tool to ChatGPT. I encourage you all to start using it. On Monday, we released it. We were piloting it before then. Srini gave me some engagement metrics from the last week or two. He said there was something like 5,000 or 6,000 messages in Gemini from employees with a couple hundred active users. And I think Gemini is going to be really useful for us for a number of reasons. But over time, right now and over time, Gemini is going to be much better at using Google Documents, Google Sheets, integrating with your Gmail and so on. So I think there's going to be some productivity gains there. So that's a lot of the enterprise tooling and how we've been using it. On the customer service side, we've been leveraging some of the AI tools that our existing software vendors have introduced. This allows for things like transcription, knowledge suggestions for question and answers during the call, and then automated summaries of calls after. It's been reported that average hold times have gone down since we've started to use that tool, so that's very encouraging. And we're exploring more uses by the day. The thing that's gotten me most excited, this has been like a 10-minute response to your simple question.
I love it.
The thing that's gotten me most excited is that, like I said, these tools have been used for developers and software engineers since 2023. And what started as this like glorified autocomplete tool that later morphed into question and answer, like asking coding questions to ChatGPT and getting answers. In November of 2025, so 5 months ago, the quality of these models had a sea change. First with Anthropic releasing Opus 4.5, and then very soon after in December with OpenAI releasing GPT 5.2 Codex or something. And by the way, when you're close to this, you're just like keeping track of all these model releases because it's usually very exciting. But there was a sea change in the quality of the output from these models. And you can see it has taken the software engineering discipline by storm. Like across the country, practitioners are leaning into these tools. It's made code generation very cheap. But what it's also done is it's basically shown us that the development life cycle for software that we've built over the last, 30 or 40 years is not going to work if you want to get the product velocity gains out of these new tools. And it's very obvious that the engineering discipline has no idea how to use these tools optimally right now. Everyone is trying to figure it out. My forecast is that it's going to take 2 to 3 years for that to happen. But we're going to be right there with the industry so that we're like on the wave. We're on the AI wave. We're not being submerged by it.
And I know Alex gets this question. Oh, thank you, Matt. That was a great answer. I know Alex gets this question from investors. You got this just at a conference last week. How will AI change the way people shop for insurance? Will people in the future be going to any carrier's website, or they can go straight to chat and input? How do you feel about that? Is this where the transformers come into play?
I think this is going to be really interesting to watch. There's a lot of forecasts for what might happen. Everything is changing so fast that everyone is a forecaster right now because no one knows how it's going to be, which is a really exciting time to be alive. But I think that what we found with ChatGPT is that they've been chipping away at the way people search for things, the way people shop for things. And whereas in the past, with insurance in particular, it was a very brand-focused approach to shopping. You know, Progressive takes up some space in my brain when I want insurance. I type Progressive into a Google bar. Now I'll go to ChatGPT and I'll ask, this is the car I have and I'm looking for insurance. What do you recommend? And so the way people search for insurance is going to be shifted, and it'll be interesting to see if that starts to degrade that brand first component of it. And I think that it will, the extent to which yet to be seen. But I think we're uniquely suited to capture that opportunity because of the focus we've had on embedded insurance. Being able to facilitate an insurance purchase within a chat application or an agentic workflow when we all have our own personal assistant agents shopping for us, the carriers that have a software layer that you can interact with, a carrier platform that you can interact with and purchase insurance, I think those are the carriers that are going to win. That requires a broad appetite for underwriting. That requires flexibility in the questions you're willing to ask and the data you're willing to ingest. And that's been our bread and butter since day one.
What advice do you have for our folks who say, there's a lot in here I don't understand or I don't know. How should I be approaching this? How should someone stay on top of it?
Yeah, there's a lot of fear and uncertainty when it comes to this AI tooling. And because it's changing so fast. It's very exciting, but jobs are changing and the way you do your job is changing. And that leads to a lot of questions about, what's going to happen to jobs and so on. And there's a lot of technology talking heads talking about this economic phenomenon called Jevons paradox. And it's really interesting. And I think it's worthwhile talking about it. And so Jevons paradox is an economic phenomenon. It was observed in the late 1800s when the steam engine was invented. And what policymakers thought would happen when the steam engine was invented and energy became much more efficient, they thought the use of coal would go down.
Makes sense.
Yeah, right. Let's use the more efficient engine. Let's use the steam engine. But the reverse happened. The demand for coal went up. When the cost of energy in aggregate went down, what happened was all these things that people wanted to do and their desires that were not economically viable before suddenly became economically viable, and demand went up. And so we were very much supply constrained in that way. And that was the paradox. And if you apply that to the AI boom that we're going through today, what is becoming cheaper now is in some ways cognition, knowledge work, and there's a huge demand on that. And rather than jobs going away as a result, I like to take the optimistic Jevons paradox view of this. I think the demand for knowledge work and cognition can only go up. And I speak, on behalf of Root, we have an ambitious goal of becoming the biggest and most profitable carrier in the world, right? We are not a steady state company. There's a long path between where we are today and where we want to be when we reach that goal. And that is supported by a long roadmap that we're not working on today. It's a backlog. It's a wrong backlog that we're not working on today. Part of the reason we're not working on it is because it's expensive to work on. And if it were to get cheaper to work on, we would scale up our employee base to work on that, not scale it down. And that's what's so exciting about this, is that it'll just accelerate our pace of innovation and our progress on that backlog and the way we get to the top. And so my advice, and this is not novel advice, you see this everywhere now. My advice is to look at the role you're in and the people in that role, not just at Root, but at other companies too. And endeavor to be the most AI skilled and AI enabled person in that role. because this is a belief. My belief is that this is a paradigm shift. And if you hold on to the old paradigm, that is a losing strategy. And so you should do everything you can to educate yourself on how to use these tools. And it's more than just ChatGPT. These tools are proliferating. It's a cottage industry. And what's great about it is the learning materials are often free. There are YouTube videos, there are blog posts. Like, you don't need to go to school to learn how to use these tools. These companies that are making very valuable tools, they want you to use them. So they make it very easy for you to learn how to use them. That would be my advice.
So we all take that advice. Squinting ahead, what are some of the big shifts you see Root having?
On the engineering side, I've kind of alluded to some of that. I think the way we develop software and product, Nick really likes to think of it as a larger chain. It's not just the software development lifecycle, but also the product development lifecycle, and I agree with him. I think the way we develop product will change. And if we do it right, I'm sure we'll hit some issues along the way. That's inevitable. But we should see a dramatic increase to product velocity. I think that in terms of our product experiences, LLMs can power much more delightful experiences, right? It could take us from a world where people are clicking on drop-down boxes and checking boxes to talking to an agent that might be agentic, or chatting with an agent that helps them understand this complex product that is insurance. On the pricing and underwriting side, this is really exciting. Like I said, we've been really focused on the machine learning methodology, but what Alex always talks about is the data flywheel, where you get more data, the models get better, your prices go down, you get more customers, therefore more data, and you keep going faster and faster. And the technology we're trying to build to make that go faster, like the asset we're trying to build in that space, is a machine that can ingest new data sources extremely quickly, come up with things, predictor variables that we think will predict, say, losses, check if those predictor variables actually predict losses, and then deploy those new models into production. And we want to speed up that life cycle as fast as we possibly can. We want to be 10 times as fast as the next insurance carrier. And I think LLMs can do that in a number of ways. I think the most obvious way is that they are remarkably good at moving and transforming data. In the first step of that life cycle, where you take raw data, sometimes structured, sometimes semi-structured, and transform it into something that predicts losses or something you care about, that has largely been a human endeavor that takes a lot of time. LLMs are uniquely suited to parsing the structured and unstructured data, constructing predictor variables, and then even doing the machine learning step, seeing if the model can predict the future. There's a prominent figure in the AI community, his name's Andre Karpathy. And just in the last week or two, he's been developing some really exciting things called auto research. So not only can LLMs do what I just said, construct the predictors that you give to the model, but since these are agentic coding agents, it can also change your model specification, the way you evaluate, and you can just have that running all the time. And so now the entire process is basically piloted by a human. You kind of guide the agent in the way that you know is right because of your expertise, but it can do 100 times the number of experiments that you can do. So very excited about how LLMs can help us in that first pillar of our strategy, being the best in the world at pricing and automation. And then finally, the other obvious place in my mind is claims. I think claims adjusters are dealing with multimodal data. It's very complex. Phone calls, emails, PDFs, photos, police reports, demand packages, and so on. And LLMs are well suited to summarizing that information and telling you where to look. And I think we can make a lot of that far more efficient. And if you allow me to dream a little bit, you think a few years into the future, if these scaling laws continue to hold, now I'm getting imaginative, but maybe this will be true, that instead of an adjuster dealing with one claim at a time, you could think of an adjuster potentially orchestrating tens of maybe hundreds of agents that are interacting with customers, getting the information we need, checking against knowledge bases, and then interacting with the human when there's a judgment call needed. Something that's outside the norm, something that's not in our historical data. Human steps in, we are uniquely suited to that type of thing when a machine isn't. So maybe wishful thinking, but I don't think it's that far out of the realm of possibilities.
Next question, when we look at larger, more tenured carriers that have mountains of predictive data, is our avenue to success more about speed of digesting that data or collecting different data?
I think it's both. So I think speed is necessary but not sufficient. I think that if all we did was collect the same data all the other carriers did, we wouldn't have a shot. I mean, I think we could be more sophisticated, we could do more deep learning research and come up with more predictive models, but I think the thing that really makes step change improvements and allows us to leapfrog those carriers with treasure troves of data is that we use new data sources they don't. Telematics was a great example of this 10 years ago. A lot of companies have caught up, but they don't use it in the way we do. We still have an edge in terms of applying it as close to that first quote as possible when it's most valuable to the customer and most valuable to the company. So yeah, I think the new data sources are going to allow us to leapfrog because if we have the speed and we identify the new data sources, the moat will continue to grow over time because even if the other carriers find the new data sources, it will take a while for them to implement them and deploy them. All the while, we'll be finding new data sources, evaluating them, deploying them into production. So I think it's both speed and data.
How would you compare and contrast Root's AI positioning with others in this space? Let me clarify, Root's positioning shared to date, because in reality, we haven't shared that much to date.
Yeah, I think it's fair to say that on a relative basis, we've spent much more time on the methods themselves internally compared to how much we spend talking about them externally. I think that Root probably values a unit of predictive power improvement more than any other company. And as a result, the way we allocate capital reflects that. We have more people focused on that problem. And that is what's going to drive results for the business. It's going to result in better prices for customers. It's going to result in better profitability for us. It's a win-win. And that's where the vast majority of our resources and time should be spent. And that's where we have been spending the vast majority of our time and resources. If I start to ask some of those people working on those problems to spend that time instead communicating them externally, every moment they're doing that, they're not working on making the models better. And so I've been reticent to do that because when it works, and it has been working, but as we get better and better, it's going to come through the results. Every quarter, we take a shot on goal. We write about our machine learning technology and what we've deployed in our shareholder letter. We talk about it in the earnings call. I'd be hard-pressed to spend more time than that.
As someone interested in this field but without direct professional experience, what resources would you recommend to help me develop the skills needed to pursue a role with Root in this area?
Yeah, I mentioned this earlier. It's amazing how much content is available for free online. YouTube videos, blog posts, like I said, these companies want you to use their products selfishly, but also their products are valuable. So they're going out of their way to providing materials to teach people how to do it. How-to guides, setup guides. I'd say find a problem in your life, whether at work or personally, that you think can be solved with one of these tools. Just take a stab at it. Starting is the most difficult part of the journey, but it's way easier than you think. Once you start working with these tools, you're going to be up all night. It's addictive. You're going to just want to keep working with them. You're like, oh my God, this is so incredible. So that would be my advice.
What's something, have you used these tools outside of work?
Yeah, my daughter, my 4.5-year-old has just started reading. And so I, within like 20 minutes, created a mobile app that, based on a list of words that I give it, it'll let her read it, and then I can hit whether it was wrong or right. And she loves playing on a phone, and I never let her use it, but this is she's so excited to use the phone. And so she's practicing her reading words, and she could just say wrong, right, and it was just kind of something fun. Hopefully, she can start developing some of these tools with me. I think she would really love that, and all my kids. It's the imagination kids have can really run wild with these tools, and they'll have a lot of fun with it.
That's amazing. We should look at branding that for you quickly. Are developments in self-driving vehicles keeping up with the general AI improvements?
I think some OEMs have remarkable technology when it comes to autonomous vehicles. That's what it was about, right? Self-driving. A lot of the methods used in that space are related to the methods used for ChatGPT, and even more so, there's a lot of effort now to apply large language model style models to what people call physical AI, like robots and auto. I have seen dramatic improvement over the last 5 years when it comes to autonomous vehicles, especially with Teslas that I don't have one, but I've ridden in them. They're remarkable. I also have never ridden in a Waymo, but I've been in a car next to one, and I was just like a fanboy, like, there's nobody at the wheel, that's incredible. I mean, I think it would be a mistake to say that they haven't progressed as fast. I think it's a slower moving, highly regulated industry, and the standards for those types of machines are far higher than the standards for ChatGPT. When ChatGPT hallucinated, everyone's like, whatever, I'm gonna keep using it. When a Waymo gets into an accident, it's a major press release. Even if Waymos are safer than humans, society still won't accept the autonomous vehicles, not as of today. It's kind of irrational in that way. So I think regulation is what's going to slow down a lot of the autonomous vehicle proliferation.
All right, last question. How can we think about AI being used to make our customers more self-sufficient in the product?
Yeah, I think there's two ways. I think the immediate way is some type of chat or voice interface to answer questions that are common and that don't require a license to answer. I think that there's seamless interfaces we can create like that, and that's kind of the obvious answer. I think, thinking a year or two ahead, when everyone has their own personal agent and they interface with products through their agent, I think the way we make it better for them is we create software for agents. We stop thinking about software purely for humans, so that, if we think about our quoting and onboarding flow or our endorsement flow as a flow that a customer opens a web page and clicks through, that is not the way we should be thinking about software for maybe a year or two out. We should be also thinking about, while that should still exist, we should also be thinking about how do we make this an agentic interface so that a personal agent can come, go through a quoting flow, and we can power it with our carrier platform.
Big thanks to Matt. We put him on the spot
Thank you.
here. Did a great job.